Hi everyone. We talked about some basic inheritance stuff, if I remember correctly. Oh, yes, yes. So we talked about basic inheritance stuff. So today we will start with some other similar topics. We will expand on previous lecture. So what we covered? We covered classes, we covered structures, we covered data members and function members. Okay. Now, if you look at the previous code here, we see that, okay, we have some bunch of functions, but to get access to this internal data members which are hidden from outside world, we also need to have some sort of data member functions. Okay, so most of the time, this is the approach we will be taking. We will add some data, we will add some member function where we can access the data members. But in case, for whatever reason, if we don't want to do that and we want to keep the function completely outside the class, we don't want to put that entire thing here, there is another mechanism, and that is called basically a friend function. So this is basically kind of like a regular function, but can access private data members of a class. So if I want to do something like this, it will looks something similar to this. So okay. So I want to have some data members. I can also have, say, string. Okay, and in private, I have a string data. Then in public, by default, what I can have here, I can have something like print data. Okay. If I have it like this, it is just regular member function. But if I do it like this, I slap another keyword called friend. And here, since I have this function, I'm going to define this basically outside. I only declare it here. I will also need a reference of this object here. Otherwise, I will have no clue which object I need to access. So for that, I can have something like this here. And then I can define it somewhere outside like this. Print data. Wait, what? And here I can simply print it. Data is data. Oh, wait, it is. And okay, we can have something like this. And let us also have another function to set this data. So void set data. It is std string data, and here we can copy data equal to double underscore data. So, okay. Now, here what we can do, we can declare an object, then set some data. This is some data, and then I can call print data obj. Okay, and I can build and run it. Okay, and here I see that it prints this data string just fine. So this here looks like a regular function, that it is not really tied to some particular class, and we call it like a regular function, not like this. Here it is a member function of this particular class. So this is basically tied to that particular class. But with this and via this keyword, I still get to access the private and protected data members of this particular class. So this is another mechanism. Most of the time, you will not really be using this. This is more like a feature of C++, just in case for some weird reason someone needs this particular functionality. So for that, it is here. Otherwise, most of the time, you will be writing some appropriate function members here directly. Okay. Now, there is a little bit of problem here. And the problem is if I have a class, okay, and in that class I am probably wrapping up some resources and some corresponding operations. For example, maybe I am writing a class which can interact with some third-party service. And that third-party service may need some sort of authentication. Okay, and most of the time when that happens, you will get some sort of authorization token, and that token, you are supposed to pass that token with each subsequent request to show that yes, you have done the authentication and this is the token, and then server will validate that token and do something for you. Or maybe you are wrapping things where you are trying to interact with some service which is something like a database, okay, where you need to connect to some particular service to some specific type of authentication and then maintain that connection, that sort of stuff. So there is obviously one way to do things, that you define a member function in that class which will do these things for you. So say you have some sort of initialization function. Okay, you call your function initialize, and whenever you declare an object, you call that initialization function first. So it is able to connect to service, do at least initial authentication, and it is basically prepared for all subsequent API requests and responses and all that stuff. Okay. So basically, what is happening here, that whenever you are going to declare an object, you have to remember that you have to call that initialization function. Otherwise, things will go wrong. Okay. So that is one way to do things. Second option is that you can say like, okay, instead of doing it this way, I can put some sort of check. Okay, so you have one extra variable in private data members. Say a variable is initialized, and you set that to true uh, when you call this initialization function. And then in all other cases, you are basically checking for that particular variable, and if it is not true, you say that okay, this object was not properly initialized, so you probably you can print some sort of error message on screen somewhere or in a log file, and probably do nothing after that. But both of these are not really ideal solutions, right? Because it is entirely possible that in your local testing, you may end up not hitting some corner cases or some specific code paths where your object does not get initialized properly. And as a result, when you deploy it, after some time has passed, somewhere something happens and you hit that particular code path where your object is not properly initialized. So either something bad happens or effectively nothing happens at all, depending upon how you have structured your code and how that external service is going to deal with you. Maybe it is simply reject all your requests and basically nothing else happens in your code. Or maybe you end up doing something uh, weird stuff. Both of these are bad. We don't want to deal with these delayed consequences. We want to basically save ourselves from all that pain. Okay. So what we do, we invent a nifty little trick, and what we say that whenever we can have a special function, and whenever we declare an object, by merely declaring an object, because I can't even use that object unless I declare it. Okay, that is simply not an option. So I can't forget to declare an object, but I can forget to call that initialization function. So we can have a special function which gets called automatically whenever I declare an object. Okay, so just by declaring an object, I am basically getting an assurance that that initialization will happen. It is not optional anymore. It is bound to happen. Compiler will generate code to make that thing happen. Okay, so if I want that nifty little trick, we can also extend it a little bit further and we can say that we may also need some sort of cleanup when the object is no longer required or it is basically nuked out of existence. Maybe we want to perform some sort of logout. We want to terminate some sort of our own network connections through which we are talking to some other service. Okay, because if we are not going to use it anymore, there is no point in basically hogging those resources and keeping that authentication session open with some other service. That is bad idea. So the same problem happens there as well. We may forget to call some other dedicated function to perform the cleanup and terminate the session, do the logout or sort of stuff. So for that, we can have another special function which works just in opposite direction. As in, whenever an object goes out of scope and it is time for it to get nuked out of memory, that deinitialization function will be called automatically because compiler will generate code like that. So that thing is not optional anymore. It is bound to happen. Okay. So we have some specific names for those functions. Okay, so one is called constructor, second one is called destructor. Okay, so this one gets called every time a new object is declared. Okay, and gets called every time an existing object is getting nuked, as in we don't need it anymore and it is time for this thing to get nuked out of memory, then this will called. Okay, and the purpose is basically simple: to ensure that our shared resources are initialized or acquired properly, and wait, initial, and the said resources are also are also cleaned up, released once those are not needed anymore. Okay, so for example, your third-party service you are using, that is a resource for you. You are using a database, that is a resource for you. You are doing some sort of HTTP API calls. The network connection itself is a resource for you. You are consuming a TCP socket for that particular thing. That itself is a resource. So whatever you use, you also need to eventually release because the resource is finite. Okay, and once you release, then it becomes available for someone else to use. Similarly, if you are trying to acquire something, it has to be available before you can use it. So these are the purposes, and let us have a constructor here. So if I want to define a constructor, for example, okay. So for constructor, I can use the class name like this. Okay, and probably I can have nothing here because I don't really need to do anything special here right now. For destructor, I can have this negation mark, and then again I can do basically nothing here because I'm not really initializing something. But for sake of demo, we can have a simple print here just to see how it is happening. Who has been initialized? Indeed. And same thing we can have here as well. Has been destroyed. Okay, and we can build this again. Okay, so here we declare this. We get this string. It has been initialized. Then we set some data. Then we print the data. That output is here. And then when it goes out of the scope, it says who has been destroyed. So basically, these functions are getting called automatically. Now, for constructor at least, I can also have parameters. Okay, for example, I want an option that instead of doing it in two steps, I want to do this in single step. So what I can do, I can define another one, and I can say here string data and data equal to underscore data. Okay. So once I have this, instead of doing this, I can have something like this. This is data via constructor. Okay. Then I can have this print object. Then I set this again and then print again. Okay, so here it says this data is via constructor. So this because we are not really printing anything here. And then we change the data, then we get the new data, and then constructor gets called. Okay. Now there will be cases where we don't really want to have it like this. We want to combine them together. So what we can do in that case, we can put default arguments. Okay. And if we have this, we also need to comment this out. Otherwise, it will become very ambiguous which function to call. Okay. So we can have obj1, we can have obj2, print data obj1, obj2, obj2. Okay. We can have it both ways then. We can build it again. and run it. Yeah, so here, since we are not really setting anything, we get the data is basically blank. So this works like just previous case. And for here, we are also able to specify some data here like this. Okay. Now, there may be cases where you do not want this thing to happen. Okay. For example, maybe you are basically writing a wrapper for some service, and to connect to it, you need some prior information, as in what is the domain name or IP address, or what is the port number, what is the username, password, or some sort of API access token, uh, those sort of details. Because without those details, you can't really do anything with that particular service. Okay. So if you allow this type of declaration to happen, that means that somewhere someone will do something like this, then he will forget to properly initialize all the parameters manually, and then something will go wrong, and then you will eventually be blamed for writing bad code, even though technically it is next person's fault. So in those cases, it is better to simply not allow this type of declaration to happen. So if I do not want this thing to happen, I basically want to force that you have to specify, you have to supply the data that I want. Okay. So for that, let me create another class. Otherwise, I will just screwing it. I will just screw it up, and then you will be confused that there were multiple things and everything is gone now. So let us suppose I have something like this class. Okay, so I define private. I have domain. I have unsigned int port number. I have username, password. Okay, so these are the things which I need to connect to some other service. So now it is time for writing its constructor. So what I want to do, wait, is screen share stop now? Let me reshare it. Okay, I hope it is working now. Okay, so API wrapper. This is my simplest constructor here. Okay, and what I will do, I will want all this information. Target service domain, service port, and service username, service password. Okay, or I can take it in separate lines here. Okay, so what I can do, I can domain equal to service domain, port number equal to service port, username equal to service username, and password equal to service password. Okay, and then probably I can also have some function like do something which as of now does nothing. Okay, so if I declare a class for this, I will just comment this whole thing out. API wrapper. Okay, if I do this, this will now not even compile. Okay, now I am getting a compilation error because this type of declaration is simply not allowed, because here I am defining a constructor and there is no version which takes no parameters. Okay, so if there is no version of constructor which takes no parameters, I can't really do this. And when I start getting error like this, I also see some suggestions that, okay, probably I need to specify some extra data here itself. Without that, I can't really even declare it. Okay, so here, basically, I get forced to provide some data. Okay, and if I specify some parameters, it will compile just fine. Now it works. Okay, I am allowed to do it like this, but not like this. Okay, now there can be cases where you want to have different number of arguments. For example, you want to allow the initialization, basically the declaration to happen with different set of parameters where you want service domain, the port, and probably you want a token. So you can define a function with three parameters, define a constructor with three parameters, and if only three parameters are getting passed at time of declaration, then you can simply initialize it that way. Okay, so that is also possible. So depending upon number of parameters and types of those arguments, the compiler can deduce exactly which type of constructor to invoke there. And by doing this, you can have your class in a way where the object can be declared with various different set of parameters depending upon which types of arguments you need to be able to do rest of the stuff that you are trying to do there. Okay, so this is the point of having a constructor. Okay, now there is another case where having a constructor will come really handy. And the another case is where you are basically trying to create one object from some other object. Okay, so you have another object already and you want to create a new object based on the previous object. We call that copy constructor. And one can ask that why can't we declare two objects and we just do object one is equal to object two? That should be possible. Yes, it is possible, but there will be cases where it will not really make any sense. For example, if you are doing some sort of you are dealing with some resource which can't really be shared by simply copying it. For example, if you are dealing with the memory on your own, you are allocating some specific chunk of memory on your own. You are not relying on these things to do the memory management behind the curtains. If you are doing that, it is fine. Okay, you can copy and the both copies will be separate and you will not really be fiddling with them across the objects. But if you are managing the memory on your own, that is where it becomes hairy, and in certain cases you can end up with situation where you have multiple objects, but they are trying to fiddle with exactly same location in memory. So you do something in one object and that has strange side effects with some other stuff in some other object, even though both are supposed to be two separate copies. So in those cases, we can have yet another constructor and where we can basically do something like this. So okay, so we can do something like this, and then we can do some stuff like this. Okay, obj dot port number and basically so on and so forth. Okay, so in that case, if we want to declare this, we can declare it like this: API2, and we specify the previous object, and we can build it and it will work just fine. This one is called actually copy constructor. And it is called a copy constructor because, well, we are copying some stuff from some other object. So some there are some special cases. So for example, it is called copy constructor. Create a new object based on some old object. Useful when some shared resource cannot be copied blindly. Okay. Now, if you are writing a class which deals with some external service, okay, in those cases, most of the time you can copy it and it will work because the shared resource is not something that is living locally in the system. Okay, not for your process at least. Memory is one example where you can't really do this. Okay, if you are creating some sort of temporary files to store some sort of temporary data, again, you can't really do this. Otherwise, from one object, you will be writing something, from other object, you will be reading something, and both will basically become a khichdi and bad things will happen. So in those cases, it is better if there are different objects. It is better if you have at least different files uh, uh, for their backing. So in those cases, you need copy constructor where you can control which data members to copy as it is and which data members are to be basically acquired fresh, and then probably you can copy data from shared resource of some other object into this object. For example, if you have some sort of backing from file, a temporary file, so instead of simply copying the file descriptor, you can create a new file, read data from old objects, a temporary file, and then rewrite into your own copy of temporary file. So you can do all that only when you define copy constructors to ensure that if some sort of things like that happen, you can actually control it that it happens in a proper way. Okay, before we move forward, any questions so far? Anyone got any questions? Okay, I think there are no questions. So we will move forward. Okay, so now I have a question. Is there some way to circumvent the previous copy constructor thing? In other words, what I want to know that if I define a copy constructor, is there any other way someone may end up uh, basically bypassing this copy constructor and doing a blind copy anyway? And the answer will be very much obvious. So if I do something, what is this? If I do something like this, it is fine. But then one can also do something like this. API 3 Okay, and accidentally somewhere down the line, one can write it something like this: API 3 equal to API 1. Okay, now here I am using the copy constructor to control how data gets copied between objects from old one to new one. What about this one? I can control the declaration part by writing appropriate constructors, but I can't really ask someone to not write code like this for my particular class, right? Even if I document it, chances are people won't read it, or they will forget it, or by mistake they will do something like this, and then it will become another problem for me to deal with, because then they will be blaming me for writing bad code. Okay, and obviously this will be a bad code if I want to deal with this stuff using a special copy constructor, and then I allow it to happen like this. Okay, so the solution is, okay, can anyone suggest me any solution for this particular case? Because this will definitely not trigger copy constructor, because, well, by the time we are here, the object on left hand side has already been declared and created, which means the corresponding constructor, whatever it was, it is started and finished. Okay, so now after that point, no constructor is going to get called. So by the time we are here, the constructor part is simply out of the question. So what can we do about this particular case? Any answers? Anyone got any ideas? Okay, I think I will take that as a no. So the solution is, we can overload the security operator itself, which means we can redefine it for our class. Compiler will emit code to call our overloaded version, and then we can handle the copy properly at our end. Okay, which means that instead of basically saying that obj1 equal to obj2 is a bad idea, we simply say that, okay, you can do this, just that we will handle this behind the curtains in our own way to ensure that things work fine. Okay, so before that, there are a couple of more topics uh, in classes. Okay, there are two more topics here. We will come back to this overloading part after it. Now, one part is static function members. Okay, and second part is abstract class. Okay, so static member function is, give me a minute, I will be back. Okay, so now we have these two topics. Now there are two cases. One case is that we want to have some sort of member function here, but we don't want to tie that function to some particular instance of the object. Okay, so by default, when we write a member function here, that gets tied to that some particular object. So when I declare an object, the member functions get tied to that. So if I do API one dot something, that member function will do something with API one only and nothing else. It can't really do, it is effectively tied to that. Okay. Now, static member functions are, which are basically not tied to some specific object of the class, and as a result, cannot access data members because it does not really make any sense because it is not really tied to some particular object. Okay, because every object will have its own copy of data members. And since the static function is not really tied to some particular object, accessing its data member is something that does not even make any sense. Okay, so in that case, what we can do if we want to have some sort of data member which is independent of object, as in it is something that gets shared across objects. So for that we can have static data members as well. So what will happen here? So it can access static data members, which are again not tied to some particular object. Okay, so how this works is it is something like this. So let us suppose I have static unsigned int counter. Okay, and what I do, I initialize it API wrapper. Uh, okay, so I need to initialize it, and this has to happen outside the class because this is not tied to that particular object. And API wrapper counter equal to 0. So now I initialize it here outside class because, okay. Now what I can do, I can have a static member function here, static void uh, increase counter, and here I can do it like this, and then I can also print it. Oh, wait. And then I can, okay, this is API wrapper, right? So here I can do something like API1 dot raise counter, API2 dot print counter. So if you note here, I am increasing it somewhere else and printing it somewhere else. So if I print here dot print counter, then increase, then print. So let us see what happens after that. Now, if you notice, I called the increase counter via object API1. I am printing for API2, and even though I called it via API1, the counter for API2 is also increased because the static data member gets shared among all the objects because it is not tied to some particular object. Okay. Now, one can ask that what is any specific use case? So, well, most of the time you will not be using this particular thing. It is just there just in case you need it for some sort of corner case. So there are a lot of things in C++ which will not make immediate sense, but they will come handy in some very specific uh, situation. So it is something like that. There are very small cases where you will actually use these static members and all that stuff. Now, abstract class is something that is way more useful, at least in my own experience. And the idea is that many times what you want to do, you want to provide some sort of boilerplate, okay? Instead of giving everything ready-made, because it may not really make sense for you to provide everything ready-made because you don't really know all the possible nitty-gritties. What you can do, you can say that, okay, I will give you a class, but you are not supposed to make an object out of it, okay? You are only supposed to derive from that class, build your own class, derive from the class that I am giving, and then use your derived class everywhere, okay? Now, why it can be useful? It is useful in cases where you want to do bunch of things which will differ depending upon specific cases, but you want to provide rest of the implementation to be as generic as possible. Okay, so for example, now suppose you are writing some sort of library or framework, or at least for your own code, you are trying to make something somewhat generic. Okay, and your only condition is that the class that you will take as parameter to do something on that particular object, that must have some particular function defined. Okay, maybe you want it to define a sort function. Okay, maybe you want it to define some sort of authenticate function or some other specific function with some specific set of arguments. So if you want to enforce that, what you do, you create an abstract class. In that abstract class, you put only those functions which you absolutely want in all the derived classes to be defined. And then in rest of the code, you take argument via a reference of your abstract class. Okay. So what happens if it is an abstract class and next person is not allowed to make an object of it, he will have to derive from it. And since we are asking him to basically define those functions and he is deriving from an abstract class, compiler will force him to define those functions. And once those functions are defined, he can use our rest of the library functions with his version of the class. Okay, and this happens via the same virtual functions that we covered in previous class, where we demonstrated that we can take a reference of base class, pass it an object of derived class, and if the function is declared to be virtual, it will resolve to correct copy of the function at runtime. And even though the function argument itself is from base class, it will call the member function of derived class instead. Okay, so basically I am generalizing my code more and more. I don't have to know about the derived class anymore. I only care about the thing that the derived class must have a function name this, return value this set of arguments. So basically, if you are coming from some other set of languages, many other languages have concept of something called interface. So there you only get a name of function and basically the parameters, and you are supposed to implement them on your own for the class where you are slapping that particular interface. And then you get other corners of the same framework or library which mandate that, okay, to call this, your class must implement this particular interface. So in C++, we don't have separate interface mechanism. We have abstract class, and this is effectively an interface if you are coming from languages like Java or C Sharp. Okay, so the idea is it is merely a template and not a full class, cannot have object of this class, can only derive from this class. Okay, so how do we define that particular thing? So we can have another class here, class abstract API wrapper. Okay, and what we can do here, we can define some public members, and let us suppose we want to have this do something function. Okay, so what we will do, what is the function signature here? So we can copy it, this, and since we want it to be virtual because we want to call the function from the derived class and not from this one, we slap that virtual keyword, and then when we end in the end, we slap equal to 0. Okay, and this becomes pure virtual function. Okay, so by putting this equal to 0, we are basically saying that we are only giving the signature of the function, and we are not going to define this function here. This is supposed to be defined by whatever class is going to derive from this particular class. Okay, so if I have something like this, and then I try to create an object, it will not compile. Here, compiler is crying that cannot declare variable abstract object to be of abstract type, yada, 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 yada. So I can't have an object of this particular class at all. But I can derive from this class. So I can derive this, and this will now compile just fine. Now what happens if I derive from this class and I don't define it? Again, if I don't define it here, then I can't really create objects of this particular class either, because by not defining it, I am inheriting this one as it is, and since it is a pure virtual function, this comes here as well, and since this class has a pure virtual function, we can't really have an object of this particular class. Okay, so if we want this class to not become an abstract class, we have to ensure that whatever base classes we are deriving from, we have to implement all those pure virtual functions. Even if we are not really doing anything and we simply do something like this where we just do nothing. Okay. Now, any questions so far? No questions today? Okay. So we will move on with operator overloading, and this will at least contains at least one pure virtual function, and syntax is basically this one. Okay, so syntax is something like this. Data type, we have function name, we have function arguments. So this is the pure virtual function. Now we come to operator overloading part. Now the idea is in some cases, some of the operations can be implemented as redefinition of some other operator. Example, for plus works as expected for numbers, we add them. Okay. For strings, plus will append them because that is what we intuitively expect to happen for strings, etc., etc. Okay. So the idea is in certain cases, instead of having a separate functions, or maybe you can have both ways, you may want to redefine some of the operators that you have in C++ language. Okay, so that they are more suited to your specific use case. Other examples are where you want to redefine the comparison. Other cases where we want to redefine certain logical operators, comparisons, etc. Okay, where we want to do it in a specific way to say whether we will consider those two objects equal or not equal. And this becomes necessary because in many cases, especially if we are dealing with some sort of shared resource, we will have different objects which will have effectively same data, but the shared resource will have some differences in it. So if we do simply blind bit by bit comparison of the data that represents that particular object in memory, we will see that those bits are not exactly the same because, well, within that object we have differences. The shared resource has different views for different objects. But outside that object, we want to say that for sake of comparison, we want to ignore that shared resource part and we only want to focus on certain specific data members to be equal. Now, one option is to have some sort of extra functions, like you can define is equal, is less than, greater than, whatever, or not equal. And then you take another object as parameter, and then you do something and return a Boolean saying that yes, it is equal, or no, it is not equal. That is one way. But then you have to uh, press some more keys every time you want to do the comparison. Okay. And the problem is then you can't really use some other functions which expect you to basically which expect the parameters to work with these operators directly. For example, if we are using things like STL, like this vector array, and we are using functions like sort, which is coming from this STL library, this can work with pretty much any object type as long as you have defined some operations for that object. So obviously that library has no idea of those special functions, but it understands the operators. So if you redefine those operators, one, you have to press less keys. Second, it becomes way more intuitive. You don't have to pay that much attention to the function. You just look at one symbol and you immediately know what is going on. Plus, you can use these super generic libraries which can work with pretty much any data type. As long as you have those operations defined for that particular data type, either intrinsically, as in it is something that is baked in C++, integer, floats, character, that sort of stuff, or you define it and then you define that particular operator for your particular class. So now we want to suppose we want to overload plus operator. That is the simplest case that is generally given. Okay. So this is the most common example that is given, and we end up having basically unsigned int, real part, and we end up having imaginary part. Okay. And what we want to do, we want to redefine this particular that plus operator for this class. Okay, so let us have a constructor, complex number, unsigned int, real equal to 0 because default arguments, unsigned int, imaginary equal to 0, and real equal to real. Wait, what? Oh, okay. This is keyword, real part, imaginary equal to imaginary. Now, if you don't want to put the different names here, that is also possible. We can just say real and imaginary. Now, this becomes confusing. Real equal to real and imaginary equal to imaginary. This becomes confusing. So, what we do, we want to specify where we are talking about these data members and where we are talking about these parameters. So what we do, we specify something like this. Okay, so this basically means that on left side, we are talking about data members of this particular object. That is what it means. So we can have a constructor. We also want to print and so let us comment This one also out. And we can have complex number 1, 2. Obviously, these can be decimals as well, but for sake of example, we are only taking unsigned integers here. Okay, so we have this, and then we can do cnum equal to print. Let us build and run. It says 1 plus 2i. Okay, fair enough. And now we want to have two of them. Okay, and I want to add them together. So one option, I can have some sort of add function like this, complex number add, and complex number reference num1, singular reference num2, and complex number result dot real equal to num2 dot real, and similarly result dot imaginary equal to num1 dot imaginary plus num2 dot imaginary, and then we can return result. Okay, so or I can have only this one. I don't really need another, basically two numbers. I can have only this one. And instead of doing this, I can do only this, and I don't want to return anything. Forget it. Okay, we can do something like this. So what I can do, I do this c num1 dot add c num2, and then do c num1 dot print again. Wait, what? Oh, wait. That is why it is going wrong. Okay, build it again. Now, before adding, it is 1 plus 2i. We add this, it becomes 4.6i. So that is one way of doing things. Second option is we don't want to do this. Okay, we want to redefine the operator itself. So the syntax is something like this: redefine plus operator, and the idea is you return a complex number, operator plus, you take a reference, and you basically return a new offset. Because when you do something plus something else, you are not changing any of the operands. So you have to do this. And now it becomes result plus real and result plus imaginary auto imaginary plus num dot imaginary. Okay, and then we return the result. And here we don't really change this current object because that is not what plus operator does. Okay, so instead of doing this, what I can do, complex number result equal to c num1 plus c num2, and here c num2 dot print, and then here I do result dot print. Okay, I build it again. I run it again, and now it works as expected. So instead of having a separate function and keeping track of which classes have defined functions with their own bespoke names and ensuring that I am calling correct function with current object, I can redefine operators appropriately, and then I can just simply write something like this. And obviously, it is shorter to type. So for the syntax, it will be return type. It can be type of your class. It can be Boolean, okay, or some other appropriate type. Then you have operator. Then you have symbolic operator itself, plus, minus, multiplication, division, whatever. Okay. Then you have argument. Again, appropriate arguments. Maybe you want to take argument of your own class only, or maybe you want to take arguments of different types. You also want to take an integer, a character, some strings, some other object from some other class. That is fine. It is up to you. Okay, so this is the general syntax, and then rest of the stuff you can do just like any other function, and we do this, and that thing basically gets called. Okay, now there are cases which where operators cannot be overloaded, and the catch is basically not all operators can be overloaded, and that is a small list actually, which means there is this keyword size of, which basically tells us size of something, which is some variable or object basically. We can't overload it. There is another one, type ID. It will come way later in the discussion because this is not something that you will be using very much, if at all. This is something that is mostly used by people who are professionally writing libraries and frameworks. Then there is the scope resolution, that is this. So if you remember, we keep doing this std double colon thing. Okay, where the hell is that? Yeah, here. This double colon is also an operator. It is called a scope resolution operator. So this is also something that can't be overloaded. Okay. So then there is this dot operator. This is called uh, class member access operator. So if you see here, we do things like object name dot some stuff. So that dot is also an operator here. Again, it cannot be overloaded. Okay. Similarly, there is another operator, and this is called ternary operator, and this is basically equivalent to if else. So if you write something like foo question mark bar colon deadbeef, it is functionally equivalent to if foo then bar else deadbeef. Both are equivalent. Okay, so most of the time you will be writing code like this, but in some cases where the logic is really, really small and you can cram that whole thing in one shot, you can also use this. Okay, but again, this is something that these are something that cannot be overloaded. Okay, so all remaining operators can be overloaded, and that again is a list. Okay, so there are basically all the unary operators. Okay, all the binary operators taking only one operand. For example, negation. Binary operators taking exactly two operands. For example, addition and subtraction. Then there are some other special operators. Some special operators. For example, this is square bracket thing. This can be overloaded. So if you remember from arrays, we were using this for indexing. So this can be overloaded. And that means that index does not necessarily have to be a number. It can be a string. It can be some other class, pretty much anything. Okay. Similarly, this function call thing that can also be overloaded. So that basically makes object of your class to behave like a function. And there are cases where this particular thing is useful, just that you will not be overloading this very much if at all. But this is something that you will be overloading at times because indexing over strings, etc., can be really handy at times, especially if you are implementing some sort of key value store. Okay, there are ready-made key value stores, but there will be cases when you want to implement your own, or probably you want to extend something from some library. In either case, if you have key of some other specific type, you can overload this indexing operator, and you can take uh, that index to be of pretty much any type you are happy with. That function call one is mostly useful for uh, basically writing libraries and functions. So if you recall that lecture where we talked about functions, we talked about uh, that std function class, which we can use to wrap specific functions, and we were doing some stuff like std bind and all that stuff. Okay, so when that thing was implemented by Boost initially, it came from Boost to C++ standard library. That initial implementation, and I think it is still the case that that particular thing is implemented by heavily uh, abusing templates, but that is something that we'll cover. We will cover later, and redefining the heck out of this bracket operators. So they basically abuse these two features, mix them together, and eventually it turned out to work like a magic. We could squint our eyes and we could just pretend that, okay, this is a function object and we can treat it like an object. But under the hood, this is what was happening there. So these are the cases where this comes really handy. Okay, now uh, then, okay, what we covered? We covered unary, binaries, some special cases. Now there is this operator. So if you recall here, we somewhere use this. Yes, this one. Okay. So this is yet another operator, and this is called dereferencing operator. Okay, so basically we are dereferencing some sort of pointer. Now, this pointer is something that we will cover a little bit later because you should not really be managing memory manually in your day-to-day life. But just for sake of record, this is something that can be overloaded. And again, this is not something that you will be using in your regular day-to-day life. New and delete both are this is for allocating memory. This is for releasing memory. Again, these can be overloaded. That doesn't mean that you should be overloading them. Okay. And this is something that we will briefly cover somewhere closer to the end of the series. Again, because you should not really be managing memory on your own because mistakes happen and then things go wrong. Okay, what else can be done? Okay, so basically all the logical operators and or not, those are those can be overloaded, and then relational can also be overloaded. So basically, this less than, greater than, less than or equal to, etc., etc. And logical is basically logical and logical or etc. All these can be overloaded, so you can redefine them as you need it. Okay. Now, any questions so far? Anyone got any questions? Our new delete overloaded, just like this. Uh, this one. So you here what you will do, you will put some return type, then operator new, and then some argument. Similarly, operator delete, some arguments. This is it is just the same syntax, just that you will have a space here. Again, it is doable. Doesn't mean you should be doing it. And as far as possible, don't even bother about managing memory on your own. Okay, you want to store some stuff, to process some stuff. There are ready-made data structures. You should be using that. You want dynamically flexible memory, use vector. You want fixed size memory buffer, use array. You want some sort of hash map, there is map. Or you want ordering to be preserved, there is ordered map. You don't care about ordering, there is unordered map. Okay, you only want some sort of key value mapping, you can use ordered or unordered map for that. you want to make some sort of pair or tuple. Pair and tuple both are fine, both are available out of the box. Okay, so most of the common cases, there are ready-made data structures. Use them. Okay, for other cases, you can probably extend them, or you can probably write your own data structures. And at that stage, you will have to kind of involve some sort of memory management. But beyond that, don't bother doing that, because once you take that much control in your own hand, you better be very, very careful with what you are taking control of. C++ will not deny you from taking the control like other languages. But as soon as you take control, it will not keep track of those things for you. Okay, so as long as you are dealing with standard data structures, classes, and all that stuff, you will basically have an assurance that you will not end up having memory leaks and double free, use after free, that sort of stuff. All that memory safety issues will not come up. As soon as you start doing that manually, those issues can come up, especially if you are not doing that via constructor and destructor. So even if you have to do that, even if in certain cases you have to allocate and deallocate memory manually, allocate via constructor, deallocate via destructor. So when you allocate an object, memory gets allocated automatically, and as soon as it goes outside scope, it gets nuked out of existence, the memory gets freed automatically. Okay, and obviously for the with that you will also have to define your copy constructor. You will also have to redefine operators like assignment operator and all that stuff. It obviously comes with all that extra hassle. Otherwise, if you say you don't redefine that assignment operator and you are tracking the memory manually, and someone does that object one equal to object two, and then object 2 goes out of scope, the memory which is backing that object 1 partially at least is now released. And now if you access that object 1 and do something with it, you are basically dealing with use after free. And just with that one tiny mistake, your rest of the code becomes potentially exploitable. So don't touch the memory management part, at least the manual part. Absolutely not, unless you are absolutely sure what you are going to do with it. Okay, any other questions? Okay, now we come to one nifty little topic. Actually, the topic is pretty long, but that is not something that is useful for your day-to-day life very much. So we will not go into too much details, but still it is uh, handy enough that it will solve a lot of your problems. Okay, and the problem says, and that next topic is basically templates. The idea is that if you have some piece of code which you want to execute at different places multiple times, and you are only changing the data. Okay, so the code is same, the data is changing. You write a function. Okay, and by writing a function, you are only basically wrapping up that fixed code. Okay, and you are just passing different values for data and be done with it. Now there will be cases where the stuff that you want to do will be very similar but not exactly same. Okay, since it is not exactly same, you can't really turn that into a function, give it a name, and use it everywhere. Okay, but again, it is similar enough that if you implement it via a bunch of different functions, like 98, 99% of the code will be same across all the implementations, and the and the minor differences will be about very small things. So in those cases, what we do, instead of writing a function, we write a function template. Okay, and it same goes for classes as well. Instead of writing a class, we write a class template. And then what happens? As required, compiler can take that template and produce produce specialized copies of either the function or the class on its own as required. So instead of tracking 10 different functions which are doing very similar things, just slightly differently, we write a template and we ask the compiler how do it. And then compiler will take care of pretty much all the remaining stuff. Okay, so let us start with some template function. Let us start with, okay, I can comment this out, this as well. Now let us suppose I want to have some sort of function, okay? And I want to do some very generic stuff, okay? And what I want to do is something like this. Suppose I want some function which gives me maximum, basically the bigger of two values. So max value, and I take int I, int j, and I have if I greater than j, return I, else return j. Okay. Now this is only for integers. Okay. Now there will be cases where I will also need this for some other types. I also need it for, say, floating point operations. Okay, or I also need the same thing for bunch of other data types where these operators are basically redefined to do something logically sane. Okay, and if I want to do the same thing for 10 wildly different data types, I will end up writing 10 versions of, basically 10 copies of this same code, and just that I will change this, this, and this, and rest of the stuff will remain same. Okay, and I don't want to do that. So instead of doing it like this, what I can do, I can turn it into a template. So instead of saying int here, I say template, and then I say type name t, and t t t. What does this mean? I am putting the template keyword, and it is saying that whatever comes after this is a template. It may be a template function, it may be a template class, but in either case, it is a template. Okay. And here I am saying that at one time, this template will work for one data type. So one data type at a time we are going to process. And then I say that let us assume that the data type is T. So if the data type is T, we return something of T, and we accept two arguments of the same type t, whatever t happens to be. Okay. Now I want to call this function. So how I will do that? Okay. It is max hash. So I want to call this. So I say, oh no, max value. Then I specify type as int, and then I specify the values. And I can build and run it. It says max of 3, max of 3 and 4 is 4. Okay. Now here I am using this operator, and if I redefine that operator here by doing overloading, that less than and greater than, I define them properly, and then I return some value. So instead of having to redefine that function for that specific type, I don't have to do that. I can just specify that type here, and as long as that operator is defined for that particular type, this will work. Now, most of the time, uh, uh, you will see this type of stuff in libraries. Okay, so if you recall from the lecture where we covered arrays and vectors, we were specifying the type of value that we were going to store. So for example, if you want, okay, let me include vector. Let us we say we have vector of, say, std string foo something like that. Okay. Now this dynamically sized vector is something that does not care too much about a specific type. Okay. So one way is just to have that you track different implementations for different types, but then the code will be similar enough that you can make a template out of it, and you can just say that, okay, let us say that type of the data that we are going to deal with, it is t, and then we will do rest of the stuff in terms of t. Okay, so if in for actual storage you want to declare 10 different objects of that, you just use the type name t, and you declare a variable of the type t. And similarly, you can have multiple types as well. Okay, so this is how it gets used, and you are just writing a very generic function. The compiler will basically end up generating different codes automatically. You don't have to do that. And that also means that if we have to fix or extend our generic template, we have to do it in one place instead of multiple different things. The only difference is here that this is basically a template class and not really a template function, but point still stands. It is still a template, and we are specifying that we are going to store a string in it. So this is template function. Similarly, we can have template class as well. And the syntax is pretty much same. We say template, then we say, let us assume that there is some type name t, and we declare some class, and let us have it public, who cares? And we want to declare a variable of type t. Okay. Now suppose we want to deal with multiple types at once. We can have type name something else, and now we can have a variable of that type as well. Oh, where one, where two. Okay, and now if we want to use this class, we can say magic. We can say std string unsigned int test magic. Okay, and if I say test magic dot var one, now if you see here, my ID is telling that var one is of type string and var two is of type integer. If I define another variable and instead of doing this, I say it is unsigned int and then I say it is unsigned char. Okay, and if I do the test magic this dot here, now those var1 and var2 are of type unsigned int and unsigned char here. Okay, so this is how this thing works. Depending upon what I specify here in types, compiler will look here, and then based on these how these are used here, it will basically create specific classes for the specific types that I have specified, and then it will just generate rest of the code using this particular template, and then I can use the class or function that is coming out of this template just like any other usual class. And the example again, vector or your array. So this is how this template part works. Again, there are a lot of things in this template part where you do basically some sort of type deduction or type erasure or forwarding or bunch of other esoteric things. But we are not going to cover any of that because those things are most helpful for people who are writing libraries and frameworks, because they have to be as generic as possible because they do not know all possible types beforehand, right? But in your cases, most of you will not be a professional C++ developer writing a library or a framework. You will be people who are going to use C++ to solve some of your own problems. Okay, so you are going to apply C++ and not enhance its ecosystem. So for that, we are not going to cover any of that. This much is covered just to give you an idea so that if you see something like this, you understand what is going on. And if you see that there is some use case where you can make a template out of something and then initialize that template for specific types and elsewhere in the code, you can use this technique to reduce the number of parallel implementations to one or two instead of having some 10, 20 different implementations which are doing effectively same thing in very slightly different manner. Okay, any questions so far? Anyone got any questions? Okay, no questions? Fair enough. So in next from next session, we will start with little bit of network side of things, and instead of dealing with raw TCP sockets and doing all things by hand like it is taught in colleges and many of your textbooks, we will do something different. Instead of going to that low level, we will involve some libraries and we will focus mostly on higher level protocols to do things. And we will mostly start with HTTP. Okay, and we will try to see how to send request, how to get response, various HTTP operations. And apart from that, we will also cover a little bit of multi-threading, because so far multi-threading was not of much use. But once you start interacting with external services, there will be cases where some other service is blocking you because it's taking some time to process your request or giving you some data. So in the meantime, you can do some other stuff while you are waiting for it. So that is where this multi-threading part comes along. So we will cover threading part after going through this network side of things. So that is what we will do in next class. If there are no questions, I suppose we can wrap this session up here.